One AI app can have 10 different failure doors. The OWASP LLM Top 10 is the map that helps you find them. The point is not to fear the model. The point is to inspect the application around it. An LLM app can read prompts, search documents, call tools, use plugins, reach databases, trigger workflows, write code, and burn money every time it runs. That is a lot of trust wrapped around one very confident text machine.
OWASP describes the top 10 for LLM applications as an awareness document for developers, data scientists, and security experts.
The 2025 list is scoped to LLM application security, which means it focuses on what happens when a model becomes part of a real system. The 2025 preface says the project grew from a 2023 community effort, then expanded with broader contributor feedback, voting, and real-world LLM application security experience. That matters because these systems now sit inside customer interactions, internal operations, and daily business workflows. Start with LLM 01, prompt injection. This is the classic LLM trap. User input, a web page, a document, or another outside source changes what the model does. Direct injection comes straight from a user. Indirect injection arrives through content the model reads. LLM 02 is sensitive information disclosure. If the app can see private data, credentials, business records, or proprietary logic, a model response can expose things that should have stayed locked up. LLM 03 is supply chain. LLM apps depend on packages, datasets, pre-trained models, adapters, hosting platforms, and outside services. A weak or tampered piece can bring risk into the whole application. LLM 04 is data and model poisoning. Bad training data, fine-tuning data, embedding data, or retrieval content can push the system toward bad answers or someone else's goal. LLM 05 is improper output handling. The model says something, and another system treats that text like trusted code, trusted markup, a trusted command, or a trusted query. That is how a sentence becomes a downstream security problem. LLM 06 is excessive agency. Give an AI agent too many tools, too many permissions, or too much autonomy, and one bad instruction can travel farther than anyone expected. LLM 07 is system prompt leakage. A system prompt can reveal internal rules, filtering criteria, permissions, or sensitive functionality. Secrets and hard security controls need to live outside the model. LLM 08 is vector and embedding weaknesses. RAG and embedding systems can help ground answers, but they also create access control, leakage, poisoning, and behavior change risks. LLM 09 is misinformation. A model can sound certain while producing hallucinated facts, unsupported claims, unsafe code suggestions, or advice that users overtrust. LLM 10 is unbounded consumption. Attackers or abusive users can flood the app with expensive requests, degrade service, drive up cost, or try to copy model behavior through repeated queries. The useful pattern is simple. The top 10 is a trust boundary map. Prompt risks sit at the instruction boundary. Disclosure and poisoning sit around data. Supply chain sits around dependencies. Output handling and agency sit where model text becomes action. Vector weaknesses sit around retrieval. Misinformation sits around trust. Unbounded consumption sits around cost and availability. Defenders should treat model input, retrieved content, and model output as untrusted until the application proves otherwise. Separate outside content from instructions. Validate outputs before they reach downstream systems. Limit tool permissions. Keep secrets out of prompts. Review suppliers. Monitor retrieval. Rate limit usage. Require human approval before high-risk actions. The model can be impressive. The security work is still mostly system design. That is the value of the OWASP LLM Top 10. It gives teams a shared map before the AI app becomes a maze.